Yeah, we are watching a map about the geothermal features of Europe, US military installations. The darker it gets, the more potential there is. And geothermal activity, I see it as volcanic activity, geysers, mud volcanoes, glaciers, and so on. And as we learned that there is much more water in Earth's crust stored than they ever imagined. Is it 100 times or 10,000 times? It doesn't really matter at the end, because if it comes up, it will be too much. Some maybe think that how it could come up. This leads us to the next theme. There is like many of those articles and say similar things. I just show now like some of them that you get a clue about. Did you know Earth has a double electrical heartbeat? Even on the fairest days without a single cloud inside, an electric current flows from the sky to the ground, driven by the difference in electrical potential between Earth's surface and the ionosphere. It is a crucial component of the global electric circuit, which connects many electrical processes in the atmosphere. So if you go a little bit down, there's a picture. And I just want to point out layer after layer after layer and layers. So there are many layers. Even our Earth's crust is in many layers sorted. So now I want to show you a part of a video which is really interesting. Levitation powers from high voltage. So that's a piece of metal floating in midair. And that's a human hand. So the voltage, the energy, goes through the human and he is still alive and nothing happens. But he's still able to make metal float in midair. So if Earth's energy circuit would get amped up, things like water, which are really good conductors, and since water is really rare in its purest form, it's always mixed up with some minerals and heavy metals and what have you, which maybe just increase the conductivity. So, about liquefaction, when the water is rising up from the ground and makes it really, really soft, like we had this quick clay thing a week or two ago. Now let's just have a look at this video. It's really, really, really interesting.
So the top plate is charged to about 70,000 volts positive, and the bottom plate is a relative 0 volts, and the object to be levitated is conductive. That's the key. The object self-regulates. Due to strong negative charges in the top plate, electrons in the object are repelled downward towards the base. The sharp corners cause higher electric field gradients, causing electrons to escape due to corona discharge. When the foil goes too high, it loses charge through corona discharge, and when it goes too low, it builds up charge separation, leading to attraction to the top plate. With the physics totally out of the way, I want to know now, what if you charge your body up to 70,000 volts or more? Will it give you the power to levitate small objects? Or will the irregularities in the shape of your hand cause problems? Perhaps the fact that your hand emits a lot of moisture so charges can leak off into the air. Will that cause problems? There's only one way to tell. Now, my whole body will be charged, and I don't want to break my mic, so I'll be taking it off so I don't break it. As exciting as this will be, it's also going to be dangerous, so use the one-hand rule at all times. So one hand in your pocket.
Earth doesn't have hands. So it will happen as it happens. There's no safety mechanisms in a way which keeps humans safe.
That prevents electricity from going across your chest. Placing aluminum foil on a plastic stool, attaching a wire to the high voltage output, then connecting that wire to the foil that I'm going to stand on, I then went to work. Straight up, it was the craziest sensation you could imagine. Not only do you feel the ionic wind on your skin, but you can actually feel the foil tugging on the palm of your hand. So I'd call this a total success. Time to move on to the smaller foil and see how that performs. Now, this blew me away. I had no idea this would happen. It kind of reminds me of quantum locking. Wherever my fingertip goes, the foil follows extremely closely and doesn't stray. Trying it on the larger foil, it still worked, just not as cleanly. Last up, I tried levitating the largest piece of foil, but I think it was a bit too heavy and couldn't get off the ground. Flight school's not for everybody. Now, I know what you're thinking, because I was thinking the same thing. How close in proximity does that bottom plate need to be? Apparently, not that close. One more quick reminder about safety. This is just so cool.
Yeah. And if you scale it up, it might be also scary. I leave it here. Thanks. Bye.